Alright, I thought I'd shoot a video on a different subject here. I think I've showed one of these before, but this is a real nice one, and I thought I'd show it and give some more in-depth view of what these things are. It looks like a maybe a typewriter or something like that. Not the right shape for a typewriter, maybe a small typewriter, but it does have a cool latch on the side, which flips open. It has a little hook here which kind of sucks it shut, which is nice, and then a big button here that slides over and releases the whole thing. So let's zoom out a bit here, and we'll zoom it out, and you can see we have a calculator inside. This is what's known as a pinwheel calculator, and the case should come off here if I take it all the way to the edge, and then the case will dislatch. There we go. Take that off. Alright, so this particular model is a Schubert, and it's made in Germany, and let's see here, let's flip it around a bit, off to the back here. So it was Schubert, made in Germany, DRV model. Is that Deutsches Republik? DRV. I'm not quite sure about that. Maybe it's Deutsches Republik. Anyway, it's a 45N231. So 45. I don't know if that's the 1945. That's one of the dates on it. The only other date that I found on it is on a casting. There's a casting over here. Oh, I don't know if you can see that. There's a casting down there that says 51. So it's either 1945 or 1951. I believe they made these up from about 1938 to about 1968. This particular model. Let's go ahead and take it off its take it off its stand here. It's got some feet on the bottom, and it just sits in there. So take that out and bring over the calculator. This one is in pretty nice shape. I should probably clean up the numbers a bit. This looks like something got spilled on it at one time, but it works very, very well. So it's a good one to demonstrate the usage of. So the first thing is that it's got a crank on it that's completely locked up, and it's got a carriage on it that's completely locked up, and it's completely locked up because it has a storage mode. So when it's in its case, you can make it all locked up so it won't shift in transportation. And so that's the first thing to demonstrate. To unlock the device, we're going to pull down on this lever here, and now the device should be completely unlocked, and we can rotate the crank. In order to put it back into locked mode, there are two levers here in the back, and what you're going to do is you're going to squeeze those two. So this one goes to the back, and then this one goes to the front, and now it's completely locked up again. And to get it unlocked, again, we'll flip this one down, and you should see this one release. There it goes. Now it's released, and now the thing can crank again. Alright. So the next thing you need to know about these things is that there's a carriage that can slide back and forth. And so you can set it to the ones column, or the tens column, or the hundreds column, that kind of thing. So there's different ways of moving the carriage. One of the ways of moving the carriage is to press down on the center thing here, and then it just slides back and forth anywhere you want it to be. So that's kind of fast mode there. If you want to shift it over just one numeral, you can put your thumb here and lift it, and it'll go one stop and then register. Go back this direction. This particular one has a nice additional mode where it has a lever down here which does the same thing, this direction and this direction. So keeps you from having to put your hand back and forth and hand back and forth. You can crank, and then you can index, and you can crank, and you can index. So that's a much faster way of doing the calculations. So that's nice. So we have ways of moving the carriage back and forth. So why do you want to move the carriage back and forth? Well, you want to add numbers in. So the way that you set a number is up at the top here. There's these little levers, and you pull the lever down and the number will change up here. So we can change it to say 3, 2, 1. So we've put in 123. All right, and then if we look down here and we crank it once, that 123 is then added into the accumulator, this register down here. So 123. So if we crank it twice, we've now added it twice, so we've added it 3 times. If we index over, instead of adding into the ones column, we're going to add into the twos column. So if we add it twice into the twos column, we can keep track of these things, like what did we do. So let's show how you keep track of how many cranks you've actually taken. So we need to know how to clear the machine. We can clear the machine by pulling down on this lever, and it clears this. We can push this forward, and it clears this. So this is a clear of the number we have set, and this is a clear of the accumulator. And so we're going to put it back to adding into the ones column, and we're going to add some things in. So let's add in the 123 again. So we're going to add that 3 times. And how do we know that we added it 3 times? Well, we can go over here, and we can see that the number 3 appears here. So we know we've cranked it 3 times. Now we're going to index it over into the tens column, and we're going to crank it twice. And again, it shows that we've cranked it twice into the tens column. And we're going to index it over again, and we're going to crank it again. So now we've indexed it, we've cranked it once into the hundreds column. So we have 123 over here, and we have 123 over here. So the way this calculator works is that we've added 123 3 times into the ones column, twice into the tens column, once into the hundreds column. That is the exact same thing as multiplying 123 times 123. So 123 over here times 123 is 15,129. So that's the way this thing multiplies. So this thing down here, remember I taught you that this thing can clear. When you clear, it clears both of these at the same time. So let's go back and we'll put in 123 again. So we have 123 and 123. It's 15,129. If we just want to clear this section, or we just want to clear this section, we can do that 2 different ways. If we just want to clear this section, we can pull this lever down. Now this lever will clear this portion of the carriage, but not this portion of the carriage. If we want to clear this part of the carriage and this part of the carriage, remember that was the whole thing. Let's go back and do the if we only want to clear this part of the carriage without clearing this part of the carriage, that's what this button is for. If we hold down this button and then we clear it, we've only cleared this part of the register and not this part of the register. So, all right. So let's show you division. We've showed you multiplication. Let's show you division. Or let's show you one fancy multiplication. Let's go ahead and let's continue on multiplication. Let's do a fancy multiplication. So we will clear everything, and we'll do 5, 2, 3, 7, 1. So the square root of 3 is 1.73205 something. So let's go ahead and, oh, I'm not in the right ones column. Go back to the ones column. Clear this, okay. 1, 2, 3, 4, 5. 1, 2. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. and 1. So 1.73205 times 1.3205 is 2.9999972.025. So we can get very accurate numbers out of this. So 11-digit mantissa out of the machine here for this particular calculation. Okay. One of the tricks that you can do with these things is how many times you have to crank it. So we had to crank this 5, 6, 7, 8, 9, 10, 17, 18 times. We had to crank it 18 times in order to do this calculation. We could reduce that number of cranks by cheating a bit. It's not cheating, it's a trick. So we'll go back here and we'll do 1, 2, 3, 4, 5. Index, 1, 2, index, 1, 2, 3, index. Now, instead of adding in 7, which would require 7 cranks, we're going to subtract 3 first. So if we subtract 3, that means we've borrowed 1 from the tens column. And so what we'll do is we'll subtract 3 in the 7, and then we'll do twice in the next column. So we'll go crank backwards. So instead of cranking forwards, we're now going to crank backwards. So we're going to do 1, 2, 3. We got a ding, which meant we overflowed, but that's okay. Then we're going to index, and we're going to then crank twice. And we've got the unding, and once again we get 2.99999972025. So we can subtract 3 and add 2, or we can add 7 and add 1. So one requires 8 cranks and one requires 5 cranks. So it saves you a bit of time. All right. So let's take a look at division. Division's a bit trickier. All right. So we'll zoom out here a bit. Okay, clear the machine. Let's divide 22 by 7. And that should give us a number near pi. That's kind of an approximation of pi, 22/7. And so we're going to put in 22. And we'll put that in here. And then we'll put in 7. And we're going to keep subtracting 7 until we get an overflow. So 1, 2, 3, and then it overflowed. But we can't go any farther, so this is not going to work very good for us. So what we're going to do is we're going to make the carriage go way over to the right-hand side here, the farthest it can go, and we're going to put in 22. Okay. So now we've put in 22, right? And now we can start subtracting 7s from that. So we can put in our 7 here. Okay, so 1, 2, 3. Okay. Once you get a ding, you add 1 back in. So now we'll do it again. Oops. Ding. Okay. So that's the way we're going to do it. And we need to count the number of times that we subtracted. Now, this is not going to work any longer. This counts additions, it doesn't count subtractions. But the machine has a way to do that, okay? It has this little lever here. When I have the lever to the right, it says plus, and when I have the lever to the left, it has minus. Okay, so minus, plus, minus. So when you're doing divisions, you need to have this little lever over to the plus. When you crank the thing forwards, it automatically puts it in the plus direction, but backwards you have to manually put it in the minus direction. So we're going to use the minus direction, and then this will count number of negative cranks. Okay? That's probably not too clear yet, but we'll do it. Okay. Okay. So we're going to then clear everything over again. Clear. We're going to index it all the way to the right. We're going to put in a number 22. We've done a positive crank, so we've added in 22. So we put it over here so that we can get a whole bunch of decimal places after that. Now we need to clear this. We're going to use this lever over here just to clear this part. So now it's cleared. And we're going to put it in the minus direction, so now it's going to be counting negative things. All right, so now we're going to put this into 7. and we're going to start subtracting sevens. When it dings, you put it 1 back in, and then we'll index it over. Index it. All right, so what number do we come up with? We came up with 3.1428571. And we can get our calculator and we can test that. Okay, what is this? This is 22 divided by 7. So, can you see that? No, you can't see that. Okay. 3.142571. So, perfect answer. So that's how you do a division on this thing. There actually is an algorithm to do square roots, but it's very complicated and very tedious. But it is possible to do square roots on this thing using a weird Taylor series expansion and using a multiple of 5, and it's quite complicated. Maybe I'll do another video on that someday. Anyway, this is the Schubert pinwheel calculator, and let me describe to you how pinwheel calculators work. I happen to have a part of a machine taken apart. This is the pinwheel. It's called a pinwheel, and I'll show you why it's called a pinwheel, because of this thing, right? And this thing is going to set in the machine where this section is. So these are the levers that are these levers. Okay, so this is out of an old machine that wasn't worth saving, so I pulled it out. So let me zoom on this and show you how these numbers are set and why this thing is called a pinwheel calculator. Alright, I'm going to set it up here so I can hold it still while I video it. Alright, I think this will work. Let's zoom in a bit here. Camera seems to be very dark. Let me reset it. Okay, so I've zoomed in here on this part of the machine that's used to set the numbers. And it's where it gets its name, pinwheel calculator. So the way these machines work is that there are gears, and in order to add 3, you need to have a gear with 3 teeth. If you have a gear with 3 teeth, then it'll add 3. If you have a gear with 5 teeth, it'll add 5. So how do you have a gear that you can change the number of teeth on? Well, that's what this thing here is. So this is a gear, and this is the next gear, and the next gear, and the next gear. So this is the 1's digits, the 10's digits, the 100's digit. And so there's a little lever back here, so the thing will not move, it's locked up. But if I push this little lever back here, then I can move the lever. And if you watch very closely right here, you'll see a little pin stick out. If I move it again, now I've got 2 pins sticking out. 3 pins, 4 pins, 5 pins. And so that's the way you set these numbers. Let me get a little bit better close-up of this. Okay, we're in a little closer here, and you can see these teeth. So there we go. You can see better those teeth sticking out. 4, 5, 6, 7, 8, 9. So anywhere from 0 teeth to 9 teeth. And these pins stick out, so it's a pinwheel calculator. And the bottom one here. So that's the way that works. And this thing's a big, giant piece of brass. These things were not made to be cheap. They're made to be rugged. Alright, that was the Pinwheel calculator by Schubert, made in Germany, post-war. Very nice machine.